Okay, so hello, welcome to Ecotek Lab. I am here with Mr. Mr. Raj from University Prep Science and Math Chemistry. Mr. Raj and I are going to be going over a session today on Charles' Law, right? So what we're going to do right now is we're going to let Mr. G start off, and we're going to share our screen so that everyone is on the same page. Okay, so I'm going to bring that up. And all right, Mr. G, you are up.
Okay. So students, so last week we have learned various laws, right? So one among them is a Charles' Law, right? So today we are going to demonstrate and we'll understand the Charles' Law experimentally in our Ecotek Lab with the help of Mr. Eng. So let's try to understand the Charles' Law. So what are the major variables involved in the law? So you must have remembered, right? So it is the volume versus temperature, right? And we even have plotted, we have done some simulations. You must have remembered that, right? Okay, so now, before we start the actual experiment, we will try to understand what are the various properties, right? Properties of the gases. What are the properties of the gases? So one of the major property that the gases exhibit is pressure, right? So what is a pressure? Pressure is nothing but force divided by area. So remember the Charles' Law, which we said, so it's about a relation. What are the main variables involved? They are the volume and temperature, right? So at constant pressure, this volume and temperature are directly related, right? They are in direct proportions. If temperature increases, volume also increases by same fold. If temperature decreases, volume also decreases by,
All right, so you guys, you heard what Mr. G is said. He's covered all the properties. He's covered the mathematics associated with calculating the Charles' Law. So now let's just talk about the demonstration, right? So we got a pretty straightforward situation here, right? So I'm going to take this guy here. I'm going to bring her a little closer, and I am going to come down. Okay, so one of our first tools here is that we got the triple beam balance, right? And the triple beam balance is specifically used to measure the mass of our balloon, right? So we started out with this balloon. We had to figure out what the mass was. But here's the deal. To really know what volume is, you need to go to a cubic unit of measurement. So 1 gram is equal to 1 milliliter. 1 milliliter is equal to 1 cubic centimeter. So we ended up going back and we said, hey, you know what? What is the volume of this balloon, right? When we brought it into here, basically we came up with 3.2 grams, which would give us 3.2 milliliters, which would give us 3.2 cubic centimeters. And we got a hot plate over here. I want to make sure I bring this hot plate in because it's going to be a special part of this whole thing, right? So our hot plate is heating up our water. So does everybody see that? Everybody got that? Okay.
let's see how does this balloon expands when you keep it in the hot water. Okay, here we go. I see it's expanding.
So you see that relationship with the temperature, you see the relationship with the volume. Once we place it in a heated liquid, the balloon just got bigger.
Okay, now students, if you think, okay, so it expanded a lot, so that's why it blew up.
So we lost the balloon. What happened to the balloon?